Now we have entered the game. Let's donate to our hero's infinite energy. First off, I switched the first character to Sturm, who has 29 health points. Greater energy give us significant chances to try, debug, and find the address reserved to a character's health. I translate 29 decimal value to relative hex, and then I use trainer start command followed by the value I want to search for. Next, I let myself inflict damage by the monster so my health points decrease. At this point, using command trainer followed by the updated value, action replay will search for all possible addresses. Okay, by searching again with the latest health value, I have obtained the address which contains that value. Using the memwatch point set followed by address, action replay should stop the program counter to the next command after that value changes. Unfortunately, the memwatch doesn't always work as expected. So while I wait for it to work, I can play by stopping game, increasing energy manually, and try again. I'll speed up the video during the play until action replay will break on the desired point. Finally, it worked. I can now disassembly starting at some point before the current program counter and search for a decrement operation. Here it is. I can replace the subtract with two no operation commands, so the length in bytes are exactly the same. Job is not finished, by the way. When main player is hit, also other non-playing characters may be affected, so I need to find another subtract instruction. Let's switch the main character with Karaman, and next, check if Sturm energy decrease with using the memwatch point. Yes, memwatch works fine. So again, I will disassemble the code early before and look for a subtract instruction. And again, I will replace the subtract code with 2NO operation instructions. Excellent. As we can see, enemies will no more inflict any real damage to our heroes. Before proceeding to patch the code in a persistent way, I want to recheck all the instructions involved so I can search for these in the two disks. Okay, now I can load Asm-One and search for that chunk of bytes to modify. The read track command load a specific number of tracks from disk to selected memory address value. Only value that belongs from chip memory area is allowed. Once the disk data is loaded on memory, we can proceed to search the opcodes to understand if are present on disk 1 or 2. Now we found two addresses relative to the crack routine. Let's check how bytecode is transformed by replacing BQ with BRA. Okay, for the next episode, we are going to disassemble the bootloop code, patch it properly, and save it on the disk. Thank you for watching.